Welcome back to Everyday Explained. Today we're breaking down how to tell if a household electrical circuit is overloaded before it becomes a tripped breaker, damaged wiring, or a fire hazard. You'll learn how circuits are rated, how to calculate safe load limits, how to test your own outlets safely, and how to solve overload problems using practical adjustments you can apply immediately. An overloaded circuit occurs when electrical demand exceeds the safe capacity of the wiring and breaker protecting it. In most homes, standard branch circuits are rated for 15 or 20 amps. When the total current draw goes beyond that rating, heat builds up in the conductors. The breaker trips to prevent damage, but not always before strain occurs. The first practical step is identifying your circuit rating. Open your electrical panel and read the number on the breaker handle. A 15 means 15 amps. A 20 means 20 amps. Do not assume. Kitchens, bathrooms, and garages often use 20 amp circuits. Bedrooms and living areas commonly use 15 amp circuits. Next, understand the 80% rule. Electrical codes recommend continuous loads not exceed 80% of the breaker rating. For a 15 amp breaker, 80% equals 12 amps. For a 20 amp breaker, 80% equals 16 amps. This margin reduces overheating during long operation. To estimate load, use the formula amps equals watts divided by volts. In North America, standard voltage is approximately 120 volts. A 1,500 watt space heater divided by 120 volts equals 12.5 amps. That single appliance nearly maxes out a 15 amp circuit on its own. Warning signs often appear before a breaker trips. Lights dim when appliances start. Outlets feel warm. Power strips buzz. You may smell faint plastic or insulation odor. These are not cosmetic issues. They indicate excessive current flow and heat. Test your theory methodically. Turn off and unplug high-wattage devices one at a time. Observe whether flickering stops or breaker stability improves. Space heaters, microwaves, hair dryers, and portable air conditioners are common overload contributors. Check extension cords and power bars. Many are rated for 13 to 15 amps maximum. Plugging multiple high-wattage devices into one strip does not increase circuit capacity. It concentrates load at a single outlet, increasing heat and resistance. Use a plug-in watt meter for precise measurement. These inexpensive devices display real-time wattage draw. Measure each appliance individually, then add totals. Compare the sum against your circuit-safe 80% threshold. Consider load duration. A vacuum cleaner drawing 12 amps for 10 minutes is different from a heater drawing 12 amps for 6 hours. Continuous load increases conductor temperature gradually. Time matters in overload assessment. Identify which outlets share a circuit. Turn off the breaker and test which receptacles lose power. Map them. Many rooms share a single branch circuit. Understanding this layout prevents stacking heavy appliances unknowingly. Frequent breaker trips are protective, not inconvenient. Resetting repeatedly without reducing load increases wear on the breaker and masks the real issue. Treat repeated trips as diagnostic information, not nuisance. If lights dim when a refrigerator or air conditioner cycles on, you may be nearing capacity. Motors require higher startup current, called inrush current. Even brief surges can push a borderline circuit beyond limits. Loose connections can mimic overload symptoms. If outlets feel hot but load calculations appear safe, consult a qualified electrician. High resistance at a loose terminal generates heat without exceeding breaker rating. Distribute load strategically. Move high-wattage devices to separate circuits when possible. Kitchens often have multiple dedicated circuits for this reason. Avoid running a microwave and toaster oven simultaneously on the same outlet branch. Upgrade only when necessary and correctly. Replacing a 15 amp breaker with a 20 amp breaker without upgrading wiring is unsafe. Circuit rating must match wire gauge. Most 15 amp circuits use 14 gauge wire. 20 amp circuits require 12 gauge wire. If overloads occur regularly, despite redistribution, you may need an additional dedicated circuit installed. This is common in older homes, not designed for modern appliance density. It is a structural solution, not a temporary fix. Smoke, discoloration around outlets, or a breaker that will not reset, warrants immediate professional inspection. These signs indicate possible conductor damage or failing breaker components. A simple prevention habit: calculate before plugging in. Add wattage ratings listed on appliance labels. Divide by 120 volts. Compare to 80% of breaker rating. This 2-minute check prevents long-term risk. Thank you for spending this time with Everyday Explained. An overloaded circuit is not random. It is measurable and preventable. Know your breaker rating, calculate your load, and distribute power intentionally. Electricity is reliable when respected. Treat capacity as a limit, not a suggestion.